Okay, so with that, so let's begin our first topic, measurements. No? So why do we have to study measurements muna? No? Because chemistry is very much dependent on measurements. No? In such way that you cannot quantify matter kasi based on their individual number. No? You cannot count atoms. So do I, no? So ibig sabihin na hindi natin kaya mag-count ng atoms. Instead, we can quantify them by measuring them using indirect methods such as using your weighing scale, so on and so forth. No? So the main reason why we have to understand measurements is that chemistry requires this, no, in order for us to quantify your matter. No? Okay, so we do measurements every day naman, no? Especially yun sa mga conscious, no? If, if kunwari nag-exercise kayo, no? So you usually measure your mass, your weight using a weighing scale. Sa mga nagda-diet, no? You check your waistline using a tape measure, so on and so forth. Pag nagpunta kayo ng malls, no? You are usually check, no? Kung ano yung temperature nyo, so on and so forth. No? So, we do this every day. So, we should be familiar with this. No? Okay, and also the fact that this has been discussed since elementary. No? So, we know this already. No? Pero we will strengthen all those ideas later on. No? So, this measurement, no? We do it every day. We live by it, no? And we should be familiar that our measurements have two components, no? So the components of measurements are the number and the unit, no? So the number tells us how much of the unit do we have, no? So ilang units meron tayo, no? Example, 5 5 centimeter. So how many centimeters do we have? 5, no? But the question is, okay, what is a centimeter? What is a meter? No? So it dates back in centuries time ago. No? So punta muna tayo sa history. No? Mag-history class muna tayo. Okay, sa measurement, no, we have three different types of measurements. No? Dating back on actually even before common era pa, no? Before Christ era, no? So there's measurements, no? We call them imperial measurements or commonly known as English system of units. Then it converted or it progressed to a much better understanding. We have the metric system. Then finally, the last and the best unit system that we have is the SI units. No? So let's have some history lesson muna. No? Teka lang. Yeah. So during old times, no, in the old civilization, they don't have any measuring devices. No? Wala silang meter stick, they don't have meter stick, they don't have weighing scale, so on and so forth. So how do they measure width, the length, the mass? No? So they do that using body sizes or physical objects. No? For example, I am the king of a certain civilization. I will start measuring everything using my body. No? So for example, this one, no, itong distance from my thumb to my pinky, we call this in Tagalog, isang dangkal, di ba? So this is actually a good measurement, no? So, for example, I have this calculator. So, sukatin ko siya. Uh, hindi pa siya umabot ng isang dangkal, no? So, I have a book here, no? Check ko. Ayun. So, this is isang dangkal, no? So, ganun yung history ng measurements dati. What they do is that they use their leader's body size in order to measure things, no? So, they use it to measure distances, no? Yung paa ng leaders nila. Kaya, we have feet measurements, di ba? 5 feet, meaning lang nun, 5 paa yung katumbas. Yeah, literally, 5 paa, no? Okay, so that's the idea. Measurement started with the idea of using body sizes, no, in order to get an idea, to get a picture on how big or how small an object is, diba? But that that is actually something that the traders do not want, no? Okay, so this is around 14th, 15th century na. So the traders do not find it fair because for them to trade their materials from one kingdom to another, they have to convert their measurements. Usually, that leads to a loss of profit. No? Nalulugi sila kasi paiba-iba yung size ng katawan ng leader nila. Okay, so, ganun yung idea. So, the body size isn't constant for every leader. We have big leaders, we have small leaders, no? So, their body size changes, hence the system of measurement changes. Okay, so for traders, they were tired of this process, and this actually led to the French Revolution. And not really on this purpose, pero uh, this is one motivation for the French Revolution to happen, no, during the Napoleonic Wars. No? Okay, so what happened is that they tried to topple down those systems. They tried to topple down imperial systems now and replace it with something that is logical, no? And something that doesn't depend on a person. So they can trade in agreement with one another. No? So that's the idea. Okay, so hence the birth of the metric system. No? So that originated in France as a result of the Napoleonic Wars, so on and so forth, the Revolution. So what happened is that they shifted the English system or the imperial system into metric system. Okay, so what's the difference? Okay, so for metric system, what they did is that they based their measurements of sizes in terms of physical objects that is not dependent on the body size of a person, so on and so forth. Instead, these are the objects that can be found everywhere. No? For example, the distance, no, can be measured in feet during the imperial times, but in the metric system, they defined meter. Okay, so what is a meter according to them? A meter is a distance from North Pole to equator passing through Paris divided by a certain number, which I don't know because it's an obsolete definition naman eh. So I don't bother. So that's the idea. Okay, so they started redefining everything using physical objects. No? So they started this measuring the distance from North Pole to equator. Then they divided it with some arbitrary constant. Then they came up with that definition that this is a meter, this is a kilogram, so on and so forth. But one most unique unique product of this shift in system is this introduction of the powers of 10, the decimal system. No? Before, they use not non-decimal systems, no? Base 12 systems, and that actually reflects sa ating orasan. No? Look at our clocks. No? Why doesn't why does it end at 12, not 10? No? Because they use old systems kasi. No? So, base 12 system sila. Yung computers natin, base 2. And tayo, base 10 tayo, decimal system. So, that's the idea. No? And those historical stuff can be still seen today. No? Just look at your clock. That is a product of a base 12 world. No? What else? Yung 12 inches to 1 feet. No? That is another product of that idea. The base 12 idea. But yun, when you are converting one stuff to another, it would be easier for you to divide it by 10 instead of 12. No? Kasi all you have to do if you divide something by 12 is to move the decimal place. Diba? Urong mo lang to the left, to the right. No? Then you have your answer. Diba? Unlike if you divide it by 2, divide it by 12. No? So yun yung idea. And that's the good side of the metric system. Number one is it lost its reliance on physical bodies. No? It is no longer uh, dependent on the leader's size. No? So whoever the king is, whoever the queen is, okay lang. Okay, because it is fixed. No? And we use that actually until this time with the introduction of the SI system. No? But anyway, these are the units that we use in metric, which we still use until today. No? All of which are defined based on physical objects. No? Yung meter, yung distance ng no, North Pole to Equator, so on and so forth. No? So yan. No? And one good thing with the measurements in metric, no, is that it introduced us the Greek prefixes that we use today. Even until now, we use them. No? That means we can expand our measurements, diba? Pwedeng maging megabytes, gigabytes, kilobytes. No? So that means yung bytes, pwede mo siya ma-expand into a very big number. No? If you have 1 billion bytes, then you have a gigabyte. No? Yun yung idea. So the good thing with metric system is that it is not only logical, it is not only based on the powers of 10, it is also expandable or contractable. No? Meaning, you can expand the definition, no? You can expand the size of your measurement. So that's the idea. Okay? So yun, if you are measuring very small stuff, for example, nanometers, no? That's a billionth of a meter, then you can use the prefix nano or the milli or the centi, na? So that's the good thing with metric system. It is revolutionary. Literally and figuratively, no? Literally because it led to the revolution in France, and figuratively because it changes everything, no? That the old system cannot address. Wala naman tayong makitang kilo feet, no? Meron tayong kilometers but not kilo feet. Wala namang centi feet, wala namang centi inches, di ba? Pero we have centimeter, kilometers, di ba? So on and so forth. So that's the good thing with metric system. It is expandable for any purposes. But yun nga, since they still have to address, no, because there are some countries that do not change their measurement system, especially the United States, no. The reason is ayaw lang nila. They don't want change, no, kaya they relied on imperial systems, no. Okay, so to address those differences, no, as the world shifts toward metric system, there are now conversion factors, no, which we have to keep in mind, no. We cannot memorize this because ako personally, I don't remember all this stuff, no. So yun. So yan lang. So that's the reason why we have conversion factors, no. We started with the imperial system that bases all measurements on body sizes. Then we shifted it with physical sizes, no, in the metric system. And just to have reference, no, or just to compare all the two measurement systems, we need conversion factors. Hence the birth of this table, which you can find in your calculators or your rulers, the back of your math notebook before, diba? So ganun. But the most acceptable in the scientific field would be the SI system or the System International de Unités. That's actually a French term. I don't know how to pronounce it, but that's the idea. The SI units. Okay, so what is SI units? Okay, so SI units is just a system of unit that is based on metric system. However, instead of basing those units in terms of physical objects, they use universal constants instead. No? So dati, a meter is defined as the distance from North Pole to Equator divided by a constant. No? Ngayon, we define a meter as the distance of light, no, as it travel, no, in 1/299 billion seconds, no? Million seconds pala rather. So yun yung idea, no? So what SI did is that it just redefined the metric system. It redefined in terms of the universality, universality of the system. No? Kasi, for example, you cannot find Earth naman on other planet, on other solar systems, di ba? So that means kailangan magbago yung definition ng meter for that planet, di ba? So unlike for SI system kasi, this is defined by something that can be found in every places in the universe, no. So yun, the photon you can find it even in black holes, no. Kahit saan ka mapunta sa universe, andun yung mga photons, andun yung mga atoms, so on and so forth. Hence, mas universal si SI system. So that's the idea. So in summary, we started with imperial systems, no? Imperial systems which bases all measurements in the size of the king and the queen. Then there came the French Revolution. Then we have the metric system which bases all measurements in terms of physical objects, not reliant on body sizes, no? So constant siya. Then the latest revolution would be the SI system, no? Okay, or the SI units. Okay, it just redefined all the metric units in terms of universal constants. So it would be applicable to any places on the universe. No? For example, may isa dito sa atin na ano pala, na alien from planet ganito ganyan. Pwede niya magamit yung idea na alam natin. No? Wala, ako taga planet ganito ako. So I have atoms, I have photons, then I can use your definition sa Earth, no, in my planet. So that's the idea. Okay? So that's the history. No? So a lot actually happened before this. No? Pero yeah, yun. Yun lang. Okay, so how do we use measurements? No? We can use measurements to measure length. No? Length is just defined as the distance from one point to another. Okay? So we can use a meter stick, a ruler. Ngayon, in the techie version, would be using IR or the AI, no? Sa mga cellphone cameras natin, no? May technology sila to measure distances using infrared light, no? Which makes use of photons again. Diba? So gamit na gamit yung light. Okay, so that's the idea. Okay, so we can measure volume using containers, so on and so forth. And what do we know about volume? That is just the length cube, no? So if we can measure length, then we can measure volume as well, no? Okay, so for regular solids, we have equations for volume. For a cube, that is just height cube. For a rectangular prism, that is linked with height, so on and so forth. So we have all those equations presented to us in our early lives sa mundo. No? So yun. So we all know this stuff. No? Mass. Okay, so what is mass? Mass is just a quantity of how much matter you have, no, in your system. For example, my mass is kunwari lang 52 kilograms. No? So that means all the particles in me, when you combine them and you measure them, it's equivalent to 52 kilograms. Okay, so it is also independent. Okay, so that means if I have this book with me, for example, this weighs let's say 200 grams. If I place this on the moon, it will still be 200 grams. No? Okay, so even I myself, no, if I go to International Space Station, ISS, which travels 400 kilometers above the surface level of the Earth, I will still have that same mass, the 52 kilograms now. What will change is my weight now. So the weight is dependent on which planet are you in, or which celestial body you are in. Okay, so yun yung idea. So the mass is not changing, however, the weight is changing due to the fact that it is dependent on gravitational constant or the gravitational acceleration. Okay, so each planet in the solar system has their own uh, gravitational constants, no? So iba-iba yung weight natin. So let's have some examples. So for example, we have 30 kilograms mass on Earth. What would be the weight, no? So all you have to do is just to multiply your mass with the gravitational constant of the Earth, no? Which is 9.8 meters per second. So you end up with 292 newtons, no? If the same person or the same body is in Mars, kunwari lang, nasa Mars tayo, the gravitational constant is 3.711 meter per second square. So what would be the weight of that object? What would be the weight of the 30 kilograms object? So let's solve. So that's weight equals 30 kilograms times 3.711 meter per second square. And I need calculator. 30. Okay. Solve din kayo ha, para masaya buhay natin. So the weight is now reduced to half, no? 111.33 Newton. So for example, you are lifting weights, no? Bubuhat kayo. Tapos gusto nyo mas madali mabuhat, you go to Mars, no? At least the weight is reduced by more than a half. Okay. So if nabibigatan kayo masyado, punta kayo sa Mars, ganun, no? So, pwede rin sa Moon, no? So ganun. So that's the idea. The mass is still the same, but the weight changes depending on the celestial body's gravitational acceleration. You would weigh more on Jupiter or the Sun itself, no? Kasi the gravitational pull is much stronger in those planets, no? On those solar celestial bodies, no? I believe sa Jupiter, that's 11 meters per second square. So that is almost double that of the Earth, no? So yan. Medyo mabigat doon, no? So let's have number 2, no? If you have a body which contains a mass of 45 kilograms, ano daw yung weight niya sa Moon? So all you have to do is to multiply 45 by this number, the constant for the Moon, and you'll end up with 73 newtons, no? If that is on Earth, no? Teka lang. Eraser. If you are going to measure the weight on the Earth, no? Weight is 45 kilograms times 9.8 meter per second square. What would be the weight? 441 newtons na. 441 newtons. So the same object with the same mass would weigh ilang times? Divided by 73. 6 times, no? It will weigh 6 times heavier than that of the Moon. That's why if you see astronauts walking on the Moon, they lifting stuff on the Moon, no? As you can see, it is easier for them to lift very heavy objects than here on Earth, no? For example, the moon buggy, no, yung moon rover, yung sinakyan nila just to travel sa moon, that weighs around 100 kilos maybe, no? But they can easily pull it, no, using their bare hands, no, because of the gravitational factor. So that's why. Okay, so we have measurements again. Yeah. Yung 1.625, that is constant for the moon. For the moon, that's 1.625. For Earth, that's 9.8. For Mars, that's 3.711. No? So, iba-iba. No? We can look up naman sa Google kung ano yung mga gravitational constants if necessary. So, ayun. No? So, again, we have different types of measurements. No? We can measure length, volume, mass, weight, and time. No? Itong time naman, this is something kasi that is outside the dimensions of 3D. No? So this is another dimension. But I just tell you how much time passed by. Di ba? Ang hirap din i-define. No? But what we know is that time is this. No? We define time as uh, a fractions of 60. No? So we have 60 seconds for a minute, 60 minutes for hours, so on and so forth. No? So yun, ito yung something na hindi na binago nila. Kasi it would be easier to just change the way you measure distances than to change the way you measure time. So yun. So itong time hinayaan na nila. That's why our clocks still have the 12 system, no? So hindi siya base 10. Okay, so the temperature. What is a temperature, no? Temperature is just the average kinetic energy of your molecules. That means your molecules are moving now. So if they move, they possess energy, and that can be translated into heat, which we convert or we usually uh, denote as the temperature itself. No? Okay, so but before that happened, no, there were two other definitions of temperature. No? Okay, so tatlo yung tao, tatlong mga taon to sa Europe that defined what the temperature is, no, or how to measure temperature. So first we begin with Fahrenheit, no. So si Fahrenheit is a physicist, no, and what he did is that he tried to make a scale of temperature of different temperature, no, based on body temperature, no. So he based his scale on body temperature. Kaninong body? Ito yung malupit, no? Based on stories, which I actually read, no? And my professor actually told me before that what Fahrenheit did is that, for example, this is my temperature probe, tinusok niya yung puwet daw ng kalabaw, no? Yan, totoo, literal yan, no? So, this is the temperature probe. He inserted it in the cow's anus, no? To measure a temperature reading. Then according to him, if this is the certain temperature, if the body is in normal temperature, meaning nun 37 degrees Celsius ngayon, no, I will call it 37 degrees Fahrenheit. No? So medyo weird. No? That's why I don't like Fahrenheit at all, because it's based on body temperatures. No? But another revolutionary way of measurement is presented by Celsius, because instead of basing the scale on body temperatures, he based his scale on water. No? So for example, I am Celsius. This is my temperature scale, and this is water. So if it is cold enough, it will freeze. Okay, so I will stick my temperature probe here, then I will wait until this freezes. No? By the time it freezes, and kung ano yung reading sa akin scale, I will say that's 0 degrees Celsius. No? But for example, I heat this water, and the time went na it started to boil. Whatever the reading on my scale is, I will say that it's 100 degrees Celsius now. And anywhere between that is just a fact. It's just a matter of factors, no, ratio and proportion stuff, no. So that's the idea. So we started with body temperature from Fahrenheit. Then we moved on with Celsius, that is based on water. Until now, we use it today, no? The Celsius scale. But why is the Kelvin scale the SI unit? No? Kasi makikita natin dito, for temperature, we use Kelvin, not Celsius. One reason, maybe, is that, sabi nga natin, di ba, that the SI system tries to make the measurement system universal. Okay, so the question would be this, no? Is there water anywhere in the universe? Hindi natin sure. Not all planets contain water. Not all parts of the solar system contains water. So that's why we cannot use Celsius, no? Instead, we can use Kelvin. So what Kelvin did is that using his understanding of physics and chemistry, he defined temperature as the kinetic energy of atoms. No? So this is now based on atoms. No? So, to prove that, no? So, kunwari, ito, dalawang kamay, no? So, pagdidikitin ko sila. So, this is one atom, this is another atom. So, I will, um, pagdidikitin ko sila. Kunwari, magdadasal tayo. Okay? So, yun. So, if the atoms are not moving, that means there is no temperature reading. Hence, the absolute zero. Pag walang gumagalaw na atom, if the atoms are not moving, there is no temperature reading. So that corresponds to 0 Kelvin. No? So yan. So if di sila gumagalaw, then yan. We don't have temperature on that. But when they started moving, no? Ano yan, gumagalaw-galaw na sila. Bilisan natin, gumagalaw sila. Ano nangyayari? Hindi ko alam kung ginagawa nyo o ako lang. No? Pero sana ginagawa nyo rin. So what you can observe is that your hands are heating up, di ba? Tumataas yung temperature. The same is true for atoms. No? If atoms are colliding with each other, ayan. So, if your hands are colliding with each other, same is true for atoms. No? If they are moving very fast, if they have high kinetic energy, they will collide with each other. And what do we know about bodies colliding? There is a friction. Okay, yung nangyayari sa kamay natin, bukod sa nagkakalibog diyan, may friction diyan. No? And that friction results to a waste of energy in the form of heat. And yun, dun nagkakaroon ng temperature reading. So that's the idea. Okay. But yun, we still use the three measurements, no, or the three units, no, just because there are countries that really do not like metric system. One of which is United States. So we have to convert one units into another. So it can be easily done. No? You can just remember these equations presented to you, or you can use your calculator because it has a built-in function that converts Celsius to Fahrenheit, vice versa. But yeah, you still have to remember this equation. So this is the equation if you are converting degrees Celsius to degrees Fahrenheit. This is the equation if you are converting degrees Fahrenheit to degrees Celsius. For Kelvin, all you have to do is to add 273.15. If you want Celsius reading to be expressed in Kelvin, and if you want Kelvin to be expressed in Celsius, you just have to deduct 273.15. Okay, so that's the idea. Important C 0.15 for me. So yeah, you should do so then. So for example, madali lang naman kasi ito. So ganyan-ganyan na muna tayo. So if we have this Fahrenheit reading 98.6, we are going to convert this into Celsius. We will use the appropriate equation. All we have to do is to plug in the 98.6 into this equation, then we'll get 37 degrees Celsius. The rest is can be done on a calculator naman. So I will not dwell on this that much now. Okay, so this one naman, if you have a degree Celsius, you want to convert it into Fahrenheit, you use the appropriate equation. That's 9/5 times degree Celsius plus 32. So you plug it in here, then you solve it using your calculator or mentally, bahala. Then you get your result of 435 degrees Fahrenheit. For Kelvin, all you have to do is just to add 273.15 to the Celsius reading. And by the way, when doing this, please keep in mind that there should be no negative Kelvins. Wala negative Kelvin. Kasi sabi natin, the limit is 0 Kelvin. The limit is 0 energy. There should no be negative energy. So yun. Yan lang. Share ko lang. So that's it na. Another ways or another application of measurement is the density. Okay, so what is density? It just tells us how much particles are compacted in a certain space or in a certain volume. Okay, so it tells us the ratio of the mass of your matter and the space it occupies. No, if they are fully compressed, then you can say that it's very dense. No, if you compare that to your daughter, for example, I drop this pencil into the water, it will sink, no, sa bottom, yun, because it is denser than the water. However, if your mass is spread out in a big space, no, for example, yung yellow, so yun, if the mass of the matter is spread out in a big space, no, then it is less dense, no. For example, if you add it on water, you will see ice floating instead of submerging because it is less dense than the water. So yun yung idea. The reason why, we will discuss it in the future topics na. So yun. Okay, so let's proceed with some examples. Then I will give you some more examples for us to solve. Okay, so by the way, bago tayo pumunta dyan, no? So, I will show you the triangle of life, no? The triangle. The triangle which I use in calculating density and all other stuff, no? Because I find it easy, no, to derive equations from this, no? Well, alam ko familiar kayo dito. Okay, so this is the triangle that I'm pertaining to. This contains the operation you need if you are looking for a variable. For example, I'm looking for density. What I'm going to do is to divide mass by the volume. Nasa taas si mass, nasa baba si volume. Okay? If I want to get the mass, all I have to do is to multiply the density and the volume. If I want to get the volume, all I have to do is to divide the mass by the density. Okay? So with this triangle, you can do operations very easy, no? Ayun. Everything in this world is run by triangles, no? So Illuminati confirmed tayo dyan. So anyway, so let's begin, no? So if we have 73.2 milliliters of a liquid and has a mass of 61.5 grams, all we have to do is to divide the mass by the volume. So we get this answer, no? By the way, the common unit for density is grams per ml. So yun yung idea. Okay, so the common unit is grams per ml or grams per cubic centimeter. And we should take note that 1 ml is equivalent to 1 cubic centimeter. That's why if you have syringe with you, hindi ko alam kung bakit kayo meron with you, pero medtech kasi kayo, no? So you should have one. So as you can see in the container, it tells you either in milliliters or in cc. Okay, what is cc? Cubic centimeter. Okay, so yun lang. Share ko lang. But the SI unit for density is kilogram per cubic meter. No? So we commonly use grams per ml, but the SI unit is kilogram per cubic meter. The question is, why? Bakit kaya? So any ideas from you? Mamaya tulog pa rin yung iba. So any ideas why the SI unit is kilogram per cubic meter? No? So any volunteers? Bakit kaya? No? Why is the SI unit for density kilogram per cubic meters? Bakit kaya? Sige, ako na lang sasagot, no? Okay, so the answer is this one. So what is the SI unit for mass? The SI unit for mass is kilograms. What is the SI unit for volume? Doon tayo magkakatalo. Tignan natin yung table. Do we have an SI unit for volume? Wala. Because we only have length, mass, time, electric current, temperature, amount of substance, and luminous intensity. We do not have volume. But what we know is that a volume is ano, volume is just defined as the length cube, di ba? Naka-cube lang yung length. And what is the SI unit for length? That's meters. So you just cube the meters, then you get this cubic meters now. Okay, but the downside of using this unit is that it is very big in terms of numbers. No, kilograms. No, we do not deal with something in kilograms, no? Especially in the laboratory. We're usually dealing with milligrams or grams of substance. No? In terms of volume, we do not use cubic meters, no? Because ano ba itsura ng cubic meter na tubig? Yung isang drum, no? That's 1 cubic meter. So we do not use isang drum in the laboratory, no? Instead, we use mLs, no? 500 ml, 1 ml, so on and so forth. So hence, there is a common unit for density. Yun lang, short ko lang. Okay, so number 2, you are given the density to siya. You have to solve for the mass, no? So using the triangle that we have earlier, so to solve for the mass, all you have to do is to multiply density and the volume. As you multiply them, make sure that the units will cancel out. Okay. So what I mean with units canceling out is that they are located on the opposite sides of the fraction. The ml here is located at the denominator. The ml is located on the numerator. Okay, with that we can cancel them now. Because if you are not able to cancel those units, then your answer is wrong. So you have to convert if necessary. Later on, we'll see how to convert those stuff now. So yun. So yun lang yung ideas na I want to emphasize. Okay, so I think this is the last one. So last one, we have specific gravity. So what is specific gravity? That is similar to density, just without the units. Density, we have the units grams per cubic centimeter, grams per ml. But for specific gravity, you just remove the units. Why is it removed? No? Because the equation for specific gravity is this. No? You divide the density of your object by the density of water at 4 degrees Celsius. No? What is the density of water at 4 degrees Celsius? That is exactly 1 gram per ml. So basically what you're doing is that you're just canceling the units. No? So yeah. Where is this used? No? Not really familiar, but I saw this on my urinalysis. No? So most likely kayong mga medtech din yung gagamit nito. I don't know why. Pwede namang density. Pero you use a specific gravity. So yun. That's not my line of field. So yan. Yeah, I saw my urinalysis result then. I saw specific gravity. This one. So okay. Yun lang. So, but yan. Moreover, no? So, hindi pala dapat moreover gamit ko. Nevertheless, no? They are similar pa rin, no? So, yun lang. Okay. So, for example, we are given a density of ethanol, which is this one. Then you're asked what is the specific gravity. The shortcut would be just remove the units. And yun nga yung sagot, no? But if you're asked what is the equation, okay, you just write this, then you divide it by 1 gram per ml. And take note that the units will cancel out. No? You use the rules for fraction when canceling units. No? So you should be able to know your fractions. No? It is a very important lesson that most students do not recognize as something necessary. No? Pero yeah, maraming nadadali sa fraction. So you really have to remember your fractions. Okay, so another problem is that we have this, no? A liquid mercury has a specific gravity of 13.6. What is the density? Shortcut is just add the unit, grams per ml. But if you're asked what is the solution, you write the equation, then you derive, no, the density of the object. No? So when deriving equations, you put the unknown variable on one side, all other known variables on the other. No? So for this case, our unknown variable is this one. No? We don't know this, but we know the density of water. So all we have to do is to cross multiply it to the other side of the equation. So we get this equation. Then we plug in the numbers, then we get the final answer. Okay. So do you have any questions? Oh, do you have any questions for now? O, sige. So, pag wala pa, let's proceed with our worksheet. No? So, let's try to answer our worksheet for us to practice all those ideas that we already know. Okay. Practice tayo. So, number 20 in your worksheet, if you don't have one, you can screenshot this screen. No? So, titanium is used in airplane bodies. No? Ay, may Lazada. So, yun. We use titanium in airplane fuselage because it is lightweight and strong. No? As compared to aluminum, yes, aluminum is strong, but it is very heavy. No? Yun, share ko lang. So, yun. Bilang naging fan ng airplanes din dati. So, yun. So, it has a density of 4.55 grams per cubic centimeter. Okay. If a cylinder of titanium is 7.75 centimeters long and has a mass of 153.2 grams, calculate the diameter of the cylinder, wherein the volume of cylinder is pi r square h. No? V is the volume, R is the radius, H is the height. No? Okay, so before we proceed with the calculation part, I want you to follow how I solve the problem, no? Para hindi tayo nalilito. So you will not be confused with what's happening in the problem, so on and so forth. There's a lot of numbers here. What are they for? No? Because yun, some students find it hard to solve equations because they don't know what to do with all the information. For you to be guided, you have to write down all the given first. What are the given ideas? Okay. So the given idea is that we have density equal to 4.55 grams per cm3. Ano pa? The length of a cylinder, L na lang, being 7.75 centimeters. What else? The mass of the cylinder being 153.2 grams. Yun lang. Okay, so those are the given information and we will see if we will be able to solve for the diameter. Okay. So, ganun yung pag-solve. No? You first write the givens. Lahat ng given na pwede. Then, you write what is asked. No? Kung ano yung kailangan. Kasi, yun. Some students do not know what is asked in the problem, so they find it hard to solve for the problem. To solve the problem. No? So, find the diameter. After that, we can write our solution. Okay, so the first thing you want to do in writing your solution is to write the equation first. No? So density is mass over volume. Then if you don't know what to do with this, you can cry na. No? But we can do this naman. Okay, so what's the idea? Density is given, diba? Mass is given. But is the volume given? Siyempre hindi, no? The volume is not given. However, we are given the equation for the volume of a cylinder. So for a cylinder of this shape, ang pangit naman yun. Insert na lang tayo ng draw. Ay, hindi pala pala. Ako talaga yung magto-drawing. Ay, ito. Ay, wala. Ay, nako. O, kunwari yan yung magandang cylinder natin. This is the radius of your cylinder. And this is the height of your cylinder. No? So, yun. What we have, no? What we have is the volume, the equation for the volume of the cylinder. So, anong gagawin natin with this information? We will use that, no? We'll plug it in the volume, no? Sabihin natin, but volume is pi r square h. So, density is mass over pi r square h. So, that's the idea, no? Then, from all those given information, mag-iisip tayo, which of those terms will give us the answer, which of those terms will give us an idea about the diameter of the cylinder. Sige. So, anyone, saan kaya makikita ang diameter? Kahit sino po pwede magsalita. Pwede rin mag-chat. Asan kaya yung diameter? Siyempre wala, no? We don't have the diameter in the equation. But, dun sa both ends po ng cylinder, dito lang tayo. Tingin lang tayo sa equation. Okay? So, using this equation, how will we be able to solve for the diameter? Well, let's recall circles, no? Circles. Ay, eraser pala yun. Ay, ito na lang. Circle. Ay, ang laki. Ay, naka. So, let's recall circles, no? So, if this is the radius, what is the diameter? That is the cross-section area, diba? So, you think may relationship si radius and diameter? Do they have relationship? If meron, sana all. Ano yung relationship nila? Their relationship is diameter is twice the radius, diba? Okay, so keep in mind that, no? So, keep in mind that the radius is twice for the diameter, no? So, yun yung idea. So, we may not have diameter in this equation, but we can get the radius first to get the diameter. So, yun yung first technique, no? After writing your equation, you have to think, where is the missing variable? Where can it be found? And we just realized that we can find our diameter using the radius. All we have to do is to rewrite the equation in terms of radius. No? So how are we going to do that? All you have to do is to cross multiply. No? So we're going to rewrite the equation. This is more of algebra instead of chemistry. No? But yeah, sciences without math is boring. So we have to understand the mathematics behind everything. No? So yun. So in order to place the radius on the other side of the equation, we have to multiply both sides by r square. Doing so, we will cancel the radius here. So that's good. But on the left side, we have density. Nakakalito naman. So we have the density on the left side. So what we're going to do is that we're going to divide both sides by the density. So we can cancel the terms. So the final equation will be r square equals m over pi h d. But still, we don't like r square. We're going to look for just the radius. So to get the radius only, we are going to get the square root of this term. So ganun yung step natin. Okay? So once we have the equation, the working equation, we can now plug in all this information. So we're going to plug in r equal to the square root of 153.2 pi. What is the height? What is the height in the problem? Ano kaya yung height? Anyone? Yung length, no? So, same lang, yung height and length, no? Pina-fancy lang, no? So, yun. I will multiply it with 7.75 cm and the density of 4.55 grams per cm cube. Okay, so that's the idea. Okay. By the way, when using pi, please do not type in 3.14. No? 3.14 is not pi because 3.14 is a rational number. This one is irrational. So what I mean by that is you cannot simplify pi now. So you have to use all the digits of the pi. So you can access that using your calculator. So I'll show you na lang. Pakita natin. So ito yung calculator nyo. Nandito yung pi usually, ayun no, sa exponential part. Yung dilaw, no, dalawan siya. So you press shift then pi. So you can access the pi, no. So magkaiba kasi yung 3.14 sa pi, no. So yun. It just so happened na ako I respect Transcendentals. Yan, igagalang natin yung pi. So yun. So use your calculators to solve for r, no. So hindi nyo kaya i-mental yan. Pag kinaya nyo yan, malupit na yun. Okay, so we will round up to the second decimal place now. Round up natin. So the answer is 1.18 for the numerical part. How about the unit? What is the unit kaya? What is the unit? Anyone? Ano kaya unit natin? G, cm square, cm, ayun, cm po. Question, bakit? No? Bakit naging cm? No. So, we will treat our units as numbers. We can cancel them, no? We can reciprocate them, so on and so forth. So, what I'm going to show this time, pakita ko how to identify the units, no? Based on your given, no? For example, I will rewrite this equation, no? In terms of units only. So, that's square root of, nasa numerator, we have G, we have grams. Okay? So for the denominator part, we have pi. Pi doesn't have any unit. So wala yun. Centimeter here. Then that is multiplied to another fraction, grams per cm cube. We can see that we can cancel grams as well as the cm, no? So pwede natin sila i-cancel. By the way, when solving, please check the units always para hindi tayo naliligaw. Okay, so by canceling all those units, we will end up with this equation, 1 over cm square. The next question will be, how are we going to deal with a fraction below a fraction? Sige. algebra tayo, grade 7 tayo. How do we deal with a fraction in a fraction? Actually, grade 5 to. Ito yung hate kong topic dati. I hate fractions before because I don't understand it, pero I just realized na I have to. Yeah. Understanding fractions make life easier. So, in order to resolve this, to resolve this equation, if you have a fraction below a fraction, we can rewrite this, in algebra. If you have a over b over c, if you have a fraction b over c below a, you can rewrite this as a times the reciprocal of the denominator. So we're just going to get the reciprocal. Yes po. So yun. So ganun din dito, So for example, another algebra, a over b over c over d, we can rewrite that as the numerator times the reciprocal of the denominator. So ganun ha. So basic algebra lang tayo. So that means I can rewrite this. I will just copy the numerator. Ito yon. So that's 1 times the reciprocal of the denominator. So pabalik na rin ko lang sila ng pwesto. So what is 1 times cm square over 1? So that corresponds to the square root of cm square. Diba? And if may square root, what can we do? We can cancel this, we can cancel the exponents, giving us a final unit for r being centimeter. So, pwede nyo yan screenshot, Now, I emphasize these minor details kasi yung mga minor na bagay, if you forget them, they will become a big issue. So, especially when you are doing calculations. So you really have to pay attention with all these ideas, Hindi porket college na is you will forget all this, No. When I was teaching in engineering class, chemistry for engineers, maraming nadadali dito, sa fractions. Madali lang mag-calculus yung fractions, hindi. Kaya yan, you have to master this. Okay, so the final unit would be centimeter. Okay, so are we done? Are we done with the problem? Ang sagot ay hindi. Kasi we are asked what is the diameter. We just only solve for the radius. But of course, this is just an easy step, finalization step. We know that diameter is twice the radius, so all we have to do is to multiply the radius by 2. Diba? So, ganun lang. So, what is 2 times 1.18? So, that's 5. Ay, ano ba? Hindi pala 5. 2.36 cm. Okay. So, that's the final answer. 2.36 centimeter. So, yeah. That's the good thing with writing your problems this way, Alam nyo kung ano yung kailangan isolve. You know that you have to find for the diameter, not the radius, So, yan. Nasundan naman po ba? Kasi if okay na tayo, we will proceed with another problem. Sige. So, yan na. As much as possible, when we are doing calculation, I try to make it as low as possible. Para masundan natin. And you can watch the video anyway after I uploaded it. So let's proceed with number 13. Sabi dyan, basahin natin. Ikalawang pagbasa. An ice cube is 2 inches on a side. Sulat ko na yun doon. So given, yung side daw ay 2 inches. and weighs 1.2 times 10 raised to 2 grams. So, isulat ko na rin yan. Mass is 1.2 times 10 raised to 2 grams. Ay, question agad. No? What is the density of ice and what is the volume of water when the ice melts? No? So, dalawa yung pinapahanap sa atin. Find A. Density of ice and density of water. Ay, but density? Volume. Yung volume of water when ice melts. No? So, ito yung idea. So, the problem tells us that we have an ice cube which is 2 inches on sides and the mass is 1.2 times 10 raised to 2 grams. We can simply rewrite this as 120 grams. No? Later on, we will understand scientific notations. So anyway, yan yung given lang. Then we have to calculate for the density and the volume. So let's write our solutions. Okay, so ano sabi ko? When writing the solutions, you have to write the equation first. No? 1 point kasi yan. No? Pag ako yung nag-check, 1 point. At least, di ba? Pag hindi nyo nasagutan, may 1 point na. Okay, so yun yung idea. Okay, so looking at the equation, we are asked kung ano yung density. So we should know the two other variables. No? Kasi in equations, no, for you to resolve that, you should only have at least one unknown variable. The rest is known. No? Because if not, you will do system of linear equations or you cannot just answer the problem at all. So check natin. So this is missing. We have this already. Do we have the volume? May volume po ba tayo? Sige. So anyone pwede po magsabi kung may volume or wala. Ano po yun? Wala po. Okay, so wala tayong volume. Hindi na natin masasagutan yan. May way ba to answer this? Siyempre, meron. Diba? So a cube is just a regular solid. No? A cube is just a regular solid. So, anong gagawin natin? We have to know the equation for cube. For a cube. Ano ba itsura ng cube? No? Ito lang yan. Ay. Using your geometry class, no? If you want to determine the volume of a cube, this is the side, di ba? The volume of a cube is just the side cube, no? So you have to multiply the sides 3 times. It's just like saying length times width times height, but for a cube, all sides are equal. So that's S cubed. No? So we know that volume is side cube. So let's just do that. So that's 2 inches cube. That will give us 8 cubic inches. Diba? 2 cube is 8. Inches raised to 3 is inches cube. Okay, so we have density and we have mass already. Meron na. We have mass, we have volume. But before we proceed, mag-reflect muna tayo sa buhay. No? Ano yung mga nagawa nating mali? No? Hindi naman na. But looking at the equation, what can we notice? The unit for mass is grams. But the unit for volume is cubic inches. Question, ano yung common unit? The common unit is grams per cm cube or grams per ml. So it would be hard if we use inches cube. Kasi kailangan centimeter. That's the common. So, ano gagawin ko dito? Sige, hulaan niyo yung word. Anong gagawin ko to resolve this issue? convert, no? So, with that, pupunta tayo sa ikalawang bahagi ng ating discussion, conversion. Okay, so welcome to the second part, no? Conversion, or the factor label method, or also known as dimension analysis, no? So, the factor label method or conversion factors, a conversion method or dimension analysis is just a procedure in which you convert one unit into the other through the help of your conversion factors. No? So yan, we are just converting one units into the other using conversion factors. Where can we find the conversion factors? Earlier, nandito yun sa PowerPoint, but we can check Google or the textbook naman, no, para makita natin yung conversions. No? So we will choose the relevant conversion factor for inches to centimeter. So alin yun? Ito yun. No? So 1 inch is 2.54 cm. Okay, so yun yung idea. Sulat natin ito. So the conversion factor for our problem is 1 inch equals 2.54 cm. Okay? Okay. Sige, okay tayo doon. Yun ang conversion factor. And to apply the idea of the factor label method, we have to multiply our given quantity with the conversion factor in order to get the desired quantity. Okay. Ano yun? No? Ganito lang yan. What is our given quantity before? Sabi sa problem, we have 2 inches. Diba? So we have 2 inches, and if you want to convert that into centimeter, you have to multiply it with a conversion factor. Okay, instead of writing the conversion factor as an equality, ang gagawin natin is we will treat it as a fraction. So we will write it down as a fraction wherein the unit to be cancelled, yung gusto mong mawala na unit, ay ilalagay mo sa opposite direction. You will place the unit that you want to cancel out in the opposite direction of the given quantity. For example, yung inches nasa numerator, di ba? So that means para ma-cancel yon, saan ko ilalagay yung inches na to? Sa denominator. So I will write 1 inch at the denominator for the purpose that they will cancel out. Cancel. Diba? How about this one? So ilalagay ko siya dito sa wala. How about this one? Ilalagay ko siya dito, no? So yun lang, very easy. So you multiply the 2, so that is 5.08 centimeter. And so ganun lang. Let's look at some other examples, no? Screenshot nyo muna kung gusto nyo. Ngayon, kaya 10 seconds. Parang nagugutom na ako, no? Kayo, pwede kayo kumain habang nag-discuss ako. Pero ako, mamaya na ako. Okay, so factor label method. So these are some examples. So suppose you're going to convert pounds to kilograms. You just have to look for the relevant conversion factor. So this 2.205 pounds equals to 1 kilogram. As you can see, the units should cancel out. Pounds and pounds will cancel out because they are on the opposite side of the fractions, no? Giving you the final unit, no? And the final equivalence. No? But there will be times that you will have to use multiple conversion factors, especially if there is no way to directly convert one unit into the other. Suppose we are going to convert gallons to milliliters. No? So to do that, we are going to use 2 conversion factors. Ito yung nasa gallons. No? You can look this up. Okay. So ano yung mangyayari? When we use this factor, ang magiging final unit would be liters, no? But if you want ml, we can use the powers of tens, no? The Greek prefixes, no? If you have 1,000 milliliters, you will have 1 liters. No? You can use your Greek prefixes for reference. No? Nasaan na yun? Ito. You can use this table for your reference. So, yun. Saan na yun? Ayan. So, yun. Okay, so what we're going to do is that we're going to cancel the gallons first. So we will end up with liters, then we're going to cancel the liters to arrive with ml. So yun lang, you have to do it multiple times if necessary. Otherwise, edi okay. No? Okay, but for this problem, no, ganito yung mangyayari sa atin. We have two ways to solve for the volume in centimeter cube, no? The first way would be, dito tayo conversion. Dalawa kasi pwede natin gawin. Pwedeng yung side, i-convert muna natin sa cm, then saka natin kunin yung volume. Pwede yan. O kaya, yung side, ginawa nating volume, inches cube, then gagawin nating centimeter cube. Okay. So, paano yan, no? Still the same. I know you know this naman, pero we will show. No? So, for A, if we're going to convert the side first into centimeters before siya gawing volume, all we have to do is to write 2 inches times the conversion factor, 1 inch, 2.54 cm, and this is equivalent to 5.08 cm. Then to get the volume, all you have to do is to cube this, no? Struggle ko. 5.08. Two decimal places tayo, 131.10 cm cube. So that's the answer, no? So that's one way. But the other way is you get first the cube, no, of the unit, then saka mo na siya i-convert. Pwede yun, no? So ginawa natin earlier, we cube this to get 8 cubic inches. Then we can convert this into centimeter cube, no? So, paano yun? Still the same. You will use the conversion factor. But this time, ito yung questions. How many times do you have to convert this? Ilang beses kaya? If I do it only once, what we can notice that may matitirang inches, may squared siya. So, hindi enough yung isa lang. Okay, so anong gagawin ko? I have to do it multiple times, no? How many times? 3 times, no? So, I have to do conversion 3 times. So, yan. Para makancel lahat ng inch, no? So, we have 3 inches here, eh. And 3 inch. So, ito yung isa, dalawa, tatlo. So, they are totally cancelled, no? We can also rewrite this, no? Kasi sa yung marker. Pwede mo naman gawing cube na lang yan. Okay. Just take note that you also cube the numbers inside, no? So, yun. By doing so, you will still end up with the same answer. Okay? So, yun yung mga methods natin. Okay, so with that in mind, we can solve for the density. So, that's mass over volume. That's, 120 grams divided by 131.10 cm cube. And the ratio would be 2 decimal places, so 0.92 grams per cm cube. So that's the answer for part 1. You just have to keep in mind the conversions. Okay, ano pa? Part 2. Letter B. What is the volume of water when the ice melts? Ito question. Sige. Ay, naantok ako. So, letter B, no? So, volume of water when ice melts. Ito yung question, no? Ibig sabihin, nagbabago yung volume pag tinanong yan, no? So, alin sa tatlo ang hindi nagbabago? Looking at the equation, looking at this equation, which of those terms will never change? Kaya, for liquids, for water, is it the density? Is it the mass? Or the volume? Sige, paunahan kayo dyan. Which of those three will never change? And that is the mass, because as I told you earlier, mass is constant regardless of where you are, who you are. No? So, ganun. No? So, mass is constant. No? That is an intrinsic property of matter. So, the volume may change. No? Kasi, to be honest with you, chapter 5 pa naman to. The volume is the space occupied by the molecules, di ba? The molecules can rearrange kasi. So, as they rearrange, they change the volume, and in turn, that changes the density. So, yun yung idea. Okay, so for letter B, still the same equation, D equals mv, but we need the volume. No? So, V is mass over density. Can cross multiply lang tayo. Okay. So, what is the mass? That's 120 grams divided by the density of the water. Water na ha, sabi dun sa problem eh. So, we get 120 ml. Okay. Okay, so with that, no, that's density. No. So, do you have any questions? Any questions are welcome. Nasundan naman po ba? Okay pa naman ba kayo dyan? Oh, sige. So with that, no, siguro I will let you answer two problems. Sige. Siguro I will give you ilang minutes. Siguro up to 12:10, no? Sige. So I will let you answer two problems, 15 and 16. Then, yun, checkan natin after 12:10. Sige. So I will give you time to check on that, no? So, yun. Yung mga gusto kumain, kumuha ng food, sige lang, no? Kuha na kayo. So, babalikan ko kayo 12:10. Sige, let's answer na, no? Because 12:10 na. Sige. Let's begin, no? Mhm. So, for number 15, no? Anong concept kaya ito, no? So, for number 15, this apply the concept of displacement method, no? So, yun lang. So, paano yun, no? So, in displacement method, if you have an irregular solid, no? And you want to determine its volume, all you have to do is to check the change in the volume of a liquid, no? So, the change in the volume of the liquid corresponds to the volume of your uh, solid, no? So, yun lang. So, let's illustrate that, no? For 15, suppose ito yung aking irregular solid, no? Yan. It has a mass of, ano ba yun? 11.33. Then what happened is that I placed that in a grad cylinder which originally contains 35 ml of water. No? As I place it down, no, syempre it's submerged. No? Then what happened is that the water rose to 43.2 ml. 43.2 ba? 42.3. Baliktad. 42.3. So the water level rose from 35 to 42.3. As I told you earlier that the change in volume corresponds to the actual volume of the solid you placed in your container. So that means we're just going to get the difference of the two volumes. So that's delta B. Delta meaning change. So the change in volume is 7.3 ml. No? And this already corresponds with the volume of your solid. So we can simply solve for the density. So that is 11.33 grams divided by 7.3 ml, which is in turn equal to, solve ko, 2 decimal places, 1.55 grams per ml. So yan. So, pag tama yung sagot, very good. Pag mali, okay lang. Hindi ko naman alam kung tama kayo o mali. So, you know your answers now. So, that's the answer. Okay, so for number 16, let's check now. 16. A waterbed filled with water has the dimensions 8 by 7 by 0.75 feet. No? Susulat natin dito. Waterbed dimensions. Sana all may waterbed. No? 8 feet by 7 feet by 0.75 feet. No? Okay, so anong pasabi dyan? Taking the density of water to be 1 gram per cubic centimeter, how many kilograms of water are required to fill the waterbed? So that means if you have a waterbed, you are going to add water until it is fully filled. No? Question is how much water or what is the weight of the water in kilograms to fill the waterbed. No? So yan. Waterbed pa ba yan? Ang laki. 8 feet. Mas malalim pa siya sa swimming pool. No? So anyway, so let's solve first for the volume. No? Yun yung munang gusto natin alamin. Bakit? We are given the dimensions. No? And this will give us idea about the volume. So we will not convert this 1 by 1 into feet kasi that will be quite intensive. What I mean is tatlong beses na siya uulitin. So what I'm going to do is that I will just convert the final unit instead. No? So 8 feet times 7 feet times 0.75 feet is equals to 42 feet cubed. No? 42 cubic feet. No? Then, ano susunod na gagawin, no? What we can do is we can convert the 42 cubic feet into cubic centimeter. Okay, so bakit cubic centimeter? Because our density is expressed in grams per cubic centimeter. So, the unit for volume should also be cubic centimeter for it to be cancelled now. Okay, so convert muna natin yung feet to inches. Ayan. Kasi wala tayong direct method from feet to centimeter. What we have is feet to inches, then inches to centimeter. So, ganun yung gagawin natin, ha? So, how many inches are there in a feet? 12 inches. How many times do we have to convert? 3 times. Bakit? Kasi naka-cube to. Yan o, cube. So, if that is cube, yeah. If that is cube, and this is raised to the power of 1, hence, we have to do this conversion 3 times. No? So, cube. So, by doing that, magka-cancel ito and ito. So, they will cancel out. 42 times 12 cube. Kopyahin muna natin lahat ng number. 72576 cubic inches. Okay, so we're not done yet. Kasi inches pa lang ito eh. The last thing that we're going to do is to convert inches to centimeter. Okay, so in 1 inch, we already knew that it contains 2.54 centimeters. No? How many times do we have to do this conversion? 3 times. Why? Because of the cube, diba? So this is raised to the power of 3. This is 1. So you have to do it 3 times. No? Para all the units will be cancelled. No? So, ay, hala, nangyari. So, wait lang, pindutin ko lang sa calcio. 42. Malaki yung number. So, okay lang. Let's write the whole number muna. 1,189,307. So, that is the dimension. 1,189,307.557 cubic centimeter. This is why I hate imperial systems. Ang hirap mag-convert. So anyway, so we have the dimension already for the volume. Okay, we're going to look for the weight of the water, the mass. Okay, so using density formula, d is equals to mv. If you're solving for mass, we can rewrite that as mass times density and volume. What we did is we just cross multiplied the equation. The density of water is said to be 1 gram per cm cube times the density of this solid is 118,307.557 cm cube. So I can cancel this and obtain a mass of 118,307.557 grams pala. Grams. But the answer requires kilograms. So, kilograms daw sabi eh. So, convert na naman. 1,000 grams, 1 kilogram. Di ba? So, I think beauty of the beauty of a metric system. If you want to convert from one prefix to another, all you have to do is to just move the decimal place. So we're dividing by 1,000, so we move 3 decimal places to the left. So, to get the final answer of 1189.32 and the 31. Round off na natin. Daming numbers eh. So that's our final answer. So ganun. Okay, so may nakita akong scientific notation, no? So yun, kasi yan yung next topic, part 3. Ay, hindi part 2 pa lang. Ay, hindi part 3 na nga, no? So sige. So, when dealing with a very big number, nakakatamad magsulat, no? Maski ako, ayoko rin na magsulat ng malaking number. So, instead na we do not answer the problem, we devise ways to simplify everything. And that is through the use of scientific notations. No? So, we're going to dive into that. No? Scientific notations. Okay. So, why do we use scientific notations? Number one, for the reason that there are huge or very small numbers that we will be dealing with in chemistry. No? So if you are counting atoms, that's more than quadrillion, that's more than pentillion. No? Kasi times 10 raised to 24, isang bowl pa lang yan, di ba? So that's a very, very huge number. So instead, no, instead of writing all those zeros, we use scientific notation. One plus side would be that it lessens the chances for you to make errors in writing the number. Kasi if you just missed 1 0, mali na yun sagot mo. Okay. So unlike for scientific notation, it is simplified for that purpose, for big and small numbers. How is it written? Okay, so it is written in this format. So that's n times 10 raised to small letter n. I call the n the integer part or the front number, and this should have a value of 1 to 9.99, so on and so forth. So what I mean by that is that its value must only be between 1.000 up to 9.99999, so on. It should not be greater than 9.999, hindi siya pwedeng 10. It should no longer, it should not be also greater than, nawala ako. It should not be less than the value of 1. So that means 0.99 is not good. Okay. So pag ganun, you have to move the decimal place again. So again, that's the first criteria that you have to keep in mind. For the front number or the integer number, the value of n should be only between 1 to 9.999. Dun lang. Okay. So how about the moving decimal point, no? So you want to indicate also kung how many times you move your decimal point either to the left or to the right, no? Teka lang. So yeah. To move the decimal point to the left or to the right, no? May corresponding ano yan, corresponding consequence, no? If you move your decimal point to the left daw, to the left, that means you are adding positive numbers to the exponent. No? Positive yung exponent. If you are moving numbers to the right, and I mean the decimal point, no? You move the decimal point to the right, you are subtracting exponents. That means your exponent will be negative in value. Let's try to make sense. Let's try to make that sensible na. So kunwari, alam niyo na yung sagot, makita niyo nun sa screen din. Pero kunwari hindi natin alam. So this is the decimal point, no? And I want this to be written in scientific notation, no? Okay, so this number itself is not in the scientific notation as this front number, itong number sa harap, no? Ano siya? That's way greater than 9.99, di ba? It's 500 eh. So I move one decimal point to the left. Pwede na ba yan? Hindi pa rin. Bakit, no? Kasi it's 56, no? And then 56 is greater than 9.999. So I have to move again to the left. If I move my decimal point here, the resulting number would be 5.68762, which is between 1 to 9.999. Okay, so that means I can write the scientific notation for this number as I move the decimal point 2 places to the left. No? Ano mangyayari? The front number will become this one, no? 5.68762. Ayun, tama naman ko na yung sinabi ko number. So, yun yung mangyayari. No? I change this number by moving the decimal point in front. So, I will be able to get the front number fit into the criteria na sinabi natin, di ba? Sabi natin, that should be only between 1 to 9.999, and yeah, we just did, no? Kasi 5 point something na lang siya. But also, you have to indicate, no, how many steps you take para makapunta sa ganong number. Sabi natin, if you move to the left, positive yung counterpart niya for the exponent. How many steps tayo papunta sa left? Positive 2. Kaya may 2 tayo dyan, no? Dalawang steps kasi to the left. No? We move the decimal point to the left twice. Hence, we have this 2 in the exponent part. Yun lang. So, how about this one? No? Kunwari, hindi natin nakikita yan. No? So, this is the decimal point. I want to write this in scientific notation. So, I should be able to write this number that fits into criteria for the integer part or the front number, which is 1 to 9.99 only. This is not, kasi it's less than 1, is 0.0 something. So, if I move the decimal point here, pwede na ba yan? Parang si Dora, no? Hindi po. Ayan, ako rin sumagot. Pwede na ba ito? Hindi rin. Pag dito, hindi rin. Dito, hindi rin. Dito, hindi rin. Siyempre, hindi dito kasi magiging 772 yan. Hindi rin pwede dito kasi magiging 77.2 yan. Dito yung best position ng decimal point. Kasi that will become 7.72, which is between our range for the front number or the integer number. So I have to move the decimal point here. How many steps? Bilangin natin. Magbibilang tayo. 1, 2, 3, 4, 5, 6. So we move 6 places to the right in order to get this integer number, the front number. So since we move 6 places to the right, that corresponds to a negative number. That's why we have negative 6 there. So ganon, no? That's how you write scientific notations. Always first write your front number or your integer number in such way that it fits the range from 1 to 9.999 only. Anything beyond that is not good. You have to move the decimal point again. Okay? And the number of steps you take for moving your decimal point corresponds to a positive or a negative exponent. No? Pag left, positive. If right, negative. Okay? Alright. So, yun lang. Okay. So, we can also do operations. Math na naman. No? We can do additional operations involving scientific notations. Okay? So, we can add, subtract, multiply, and divide scientific notations. So, paano yan? No? For addition and subtraction, keep in mind that you should have the same exponent. No? Yun. You have to rewrite your scientific notation in such way that it will give you the same exponent. No? For example, we have here sa number 1. Ano meron dyan? Okay. For number 1, as you can see, 10 raised to 3 and 10 raised to 3 are the same. Bakit sila kailangan parehas? Why should they be the same? Because what we're going is that we're going to copy them lang. Ayun, kukopyahin lang kasi natin. No? So, asan yung operation part, no? We're going to deal with the operations for the front numbers, no? Ito. So, for addition, of course, you will add them. For subtraction, you will subtract them, no? So, for number 1, that is 7.4 plus 2.1, that is 9.5. For the exponent part, you just have to copy it, no? Kopyahin mo lang, no? Yan, kopyahin mo lang yan. Okay? So, how about if the exponents are not the same? No? For example, number 2, we have 10 raised to 4 and 10 raised to 3. Okay? In such cases, kailangan merong mag-adjust. No? Sino yung mag-a-adjust? Kayo bahala kung ano gusto nyo. Pwedeng yung 4, pwedeng yung 3, pero hindi pwedeng wala. Okay? So, ang ginawa niya dito sa problem, no, is ginawa ng PowerPoint is in-adjust niya si 3 to become the 4, no, to be raised to 4. Paano yun, no? Sulat natin. So, this is 3.9 times 10 raised to 3. If you want to make the exponent 4, you just have to move your decimal point to the left. Kasi as I told you kanina, every time you move to the left, positive 1 ang katumbas. So, we have to move 1 step to the left so we can add 1 sa exponent. So, we can rewrite this as 0.39 times 10 raised to 4. Diba? Easy. Ayan o. Ayan siya. Then, after doing so, you can copy these exponents since they are already the same, and you can add these numbers. 4.31, 4.39, 0.39, that's 4.7. Okay. Sir, paano kung gusto ko times 10 raised to 3, yung parehas? Sige, pakita natin. So, if you want your exponent to be 3, so, we will adjust this number instead of this. So, I will show you that it will still yield the same answer. Okay? So, that's 4.31 times 10 raised to 4 plus 3.9 times 10 raised to 3. So, if I want this number to be raised to 3, all I have to do is to move my decimal point to the left. As I told you again, no, I want to reiterate always, no, para maisip natin always. So, every time you move to the right, that corresponds to a negative 1 value for the exponent. So, I moved 1 step to the right, so my exponent is decreased from 4 to 3. I can rewrite that as 43.1 times 10 raised to 3 plus 3.9 times 10 raised to 3. So, for the answer, I'm going to copy the exponent only, and I'm going to add this integer part, the front number. So, 43.1, kunwari inisip ko pa, 47 lang yan, 47.0. But again, as I told you, this is not the final answer, as our scientific notation should contain an integer part that only exists between 1 and 9.999. 47 is way beyond 9. So we have to move 1 decimal point again to the left, no? Increasing the exponent by a factor of 1. Hence, the final answer is still the same. So, ganun lang ha. Every time you move, may positive and may negative counterpart siya for the exponent. So, yun, ganun din naman yung sa 3, no? So, hindi ko napapakita, no? So, you can try that at home, no? So, yun na. So, are we clear with addition and subtraction? Okay naman po tayo dyan. If you have question, you can ask, no? Para okay tayo. Treat your classes as parang relationship. Pag hindi nyo kinausap, walang mangyayari. So you really have to ask, no? Okay ka pa ba? Ano na nangyayari? Mga ganun na. So you have any questions, just message it sa chat na. Anyway, I will proceed with the multiplication and division. So for addition and subtraction, I have to always keep in mind that they should have the same exponent. But for multiplication and division, it is not necessary, as those exponents are also used in the operation. Remember in your algebra, when we multiply or divide the exponents, when we multiply or divide numbers, we adjust the exponents now. For multiplication, we add them. For division, we subtract them. The same is true for scientific notations. No? So, ganun, we will do two separate operations. No? So, separate yung operation for the integer part. So, that's 4 times 7, 28. Then, iba yung operation for the exponent. We will do the other operation for the exponent. For multiplication, that's addition. So, you will add 5 and 3. Negative 5 plus 3 is negative 2. Hence, the exponent negative 2. And again, this is not yet the final answer because 28 is way above, way higher than 9. So I have to move the decimal point again. And as I move it to the right, we will add 1 here. So it will become a negative 1 exponent. Okay? So ganun lang. For division naman, on the other hand, instead of adding the exponents, we subtract them. Okay? So the same is true. You will divide the integer numbers. Ito yon, that corresponds to 1.7 daw. And you subtract the exponents. So what is 4 minus 9? Negative 5. And for this case, we do not have to move the decimal point any longer as it fits the criteria for the integer part. No? So, ganun lang, no? So, to summarize, addition and subtraction requires you to have the same exponent. You can do that by adjusting your decimal point to the left or to the right. No? Then you can add the integer part or the number part. No? For multiplication and division, regardless of what exponent it may be, you just add them or subtract. No? For multiplication, you add the exponents. For division, you subtract the exponents. So that's it for scientific notation. Again, no? Last one. Last one na tayo. Okay, so dito naman tayo, significant figures. No? Okay, so in measurement, not all numbers are important. No? Parang tao yan. Everyone plays a role, but not all are important. No? Lalo na sa mga pag-ibig na yan. No? So, ganun din dito. Hindi lahat ng numero, hindi porket may value ka, importante ka, or significant ka because of the rules. No? Okay, so tingnan natin yung rules for the scientific significant figures rather. Okay, so we have 5 rules to deal with and madali lang sila. Okay, so rule number 1, all non-zero digits are considered significant. So when you say significant, they matter. Ay, ano nangyari? Naipit ng... Ayun. Okay, so anyway, so all non-zero digits are significant. So that means any number except 0 is significant. We can call them significant numbers. For example, I have 5, 3, 2, 1. Mamaya na yung 0. 5, 3, 2, 1. It contains how many significant figures? Bilangan natin 1, 2, 3, 4. 4 significant figures siya. If we have a number 9355. 4 significant figures din yan. As long as the number is non-zero, it is significant always. Okay, so the next rules are about zeros. Okay. Ito muna yung gawin ko ito. Nasanay ako eh. Sa 23. Okay. So, rule number 2 is that if you have zeros between non-zero digits, you consider them significant. No? For example, 101, the zero is in between 1 and 1, di ba? So, those numbers are significant. Hence, this zero na nasa gitna will also be considered significant now. So in this case, we have 3 significant figures. For 1001, we have 2 zeros in between 2 non-zero digits. Yung 1 and 1, they are non-zero digits. Atong zeros na nasa gitna nila. So we consider them significant. So we have 4 significant figures here. 5 o 5,000, 5, ganun din. 5 and 5 are significant, hence the zeros in between them are significant na. So that's 4 significant figures. So that's rule number 2. Rule number 3. Okay, before we proceed, let us discuss the 2 types of zeros. We have 2 types of zeros. We have the trailing and the leading zeros. Okay, so dalawa yung uri ng zero. We have leading zeros and trailing zeros. From the word itself, leading, it is the zero, or these are the zeros in front of the first non-zero digit. For example, 0.00012. Okay. So these zeros, etong mga to, okay, so this is the first significant digit, di ba? Yung 1 because it is non-zero. All these zeros in front of it are called the leading zeros. Ano yung sinasabi ng batas dyan, no? According to rule number 3, ito yung rule number 3 ko. According to the third rule, zeros at the beginning of a number are never significant. That means leading zeros are not significant. So, ano sila, no? So, their purpose only is to indicate the position of the decimal point. No? They only indicate where the decimal point is. No? So, ganun lang. Yun lang yung purpose nila sa life. No? They just indicate the location of the decimal point for you to see kung anong type ng number yan. So, that's leading zeros. Trailing zeros, on the other hand, these are zeros after the last significant figure. No? So, for example, 120, 0, 0, ay klaro yan, 0.01 to 000. Okay, so, dalawang part ng zeros meron tayo dyan. This part, yung nasa green, this part are called the leading zeros. No? Leading. On the other hand, this part, yung orange, we call these zeros the trailing zeros. Okay. So, are they significant? Yes, they are significant, pero may catch. If it only contains a decimal point. Now, that means trailing zeros are significant only if there are decimal point. There is a decimal point now. Okay, so pag walang decimal point, they are not significant. No? Or may be significant, no? In times or in cases that we don't have a decimal point but we have a trailing zeros, dun papasok ang rule number 5. So, what is rule number 5? It tells us that if there is no decimal point but we have trailing zeros, there is a case of ambiguity. Ambiguity or ambiguous, that means we don't know and it is prone to different interpretations. For example, I have here 400. I can interpret that as 4 times 10 raised to 2, which contains 1 significant figures. Paano yung basis ng significant figures for a scientific notation? We only look at the integer part now. So the integer part or the front number contains 1 significant figure. So that number contains 1 significant figure. I can also interpret 400 as 4.0 times 10 raised to 2, still the same number, but with 2 significant figures. I can also interpret that as 4.00 times 10 raised to 2, which contains 3 significant figures. I can also interpret that as this number, 4.00000 times 10 raised to 2, which contains 6 significant figures. So as you can see, without the decimal point, there are lots of interpretation about the number. So it's important to place the decimal point. So what's the resolution? So in cases of ambiguity, we have 2 ways to resolve the case now for it to be significant. Number 1, we can write them in scientific notations. You can write them in scientific notations para you can see how many significant figures are there. Or the simplest way is just to add a decimal point at the end. Adding a decimal point at the end will make all those trailing zeros significant. So yung 400, ambiguous, lagyan mo ng tuldok, 3 significant figures. Yung 5,000, that's ambiguous, lagyan nyo ng tuldok, place a dot, 4 significant figures yan. So that's how we deal with significant figures. So yan yung rules natin. No? You can take a screenshot so we can proceed with the last slides. Gugutom na ako. Ayan. So anyway, let's proceed. No? If we have operations with scientific notations, there should be also operations with significant figures para masaya. Okay, so this is the first operation involving significant figures, multiplication and division. All we have to take note is that our final answer should be represented in terms of the least number of significant figures. No? So we follow the least number of significant figures. Let's consider this. For example, we have 2.8 times 4.5039. Okay, let's see how many significant figures are there for each number. So for this one, we have 2 significant figures. For this one, we have 5 significant figures. So alin sa dalawa yung mas maliit, no? Which of the two is the least significant figures, least number of significant figures? Of course, the answer is 2 significant figures. So you multiply the numbers as is, but you represent your final answer with the least significant figure. So kailangan daw 2 significant figures. So let's start counting the significant figure. This is the first. This is the second. We end here. Sir, paano yung number sa kabila? Okay. So if you have a number on the right side, you have to consider them then. No? If that number is greater than 5 and above, no? That means you have to round it up. No? If that number is less than 4, 4 below, you round it down or you just disregard that. So to write this in correct significant figures, we round it up to 13. The final answer for that one is 13 because of this 6 now. So the same is true for division. So here we have 3 significant figures. We have 5 significant figures. The least significant figure is 3. So this is our final answer. This is the quotient, no? But the final answer should be written in 3 significant figures. So how are we going to start counting for the significant figures? Madali lang, no? This is not significant, so we skip. This is not significant as well because it is a leading 0. This one is significant, so we begin counting here now. So 6. So this is the first significant figure, second significant figure, and the third significant figure. So we end here. Then let's look at the number at the right side. So this is 3. So this is less than 5. So we can round it down now, or just simply neglect it now. So we will write our final answer as 0.0611. So ganon. So yun. Those are the rules for multiplication and division. You always follow the number with the least significant figures. How about addition and subtraction? For addition and subtraction, instead of counting the significant figures, we count instead the decimal places. Now, we report the answer with the least decimal places. Okay? So, tingnan natin. Kunwari, hindi nyo nakita yung sagot. No? So, this is the number, 89.332 plus 1.1. This is the answer. This is the sum. Okay? So, ano na gagawin natin dyan? No? So, let's count the decimal places. No? So, we begin counting the decimal places right after the decimal point. So, this is the first decimal place, the second, and the third. So, we have 3 decimal places there. Dito naman, we only have one number after the decimal point. So, we have 1 decimal point. So, in our final answer, we cut the number at the first decimal place. Kasi ito yung list eh. So we end here. We look at the number on the right side. So that is 3. So anong gagawin? Round down. Round down, meaning you're just going to neglect them. And the answer is 90.4. Okay. So for subtraction, ganun din, we have 1, 2, 3. 3 decimal places here and 2 decimal places here. So we follow the 2 decimal places. No? So we subtract it as is and we end at the second decimal point, no? Or the second decimal place. Okay, looking at the number on the right side, that is 7. And we round it up, diba? Round up pag 5 and above. So we will end up with the answer 1.98. So that's the rule for addition and subtraction. You follow the least decimal place. For multiplication and division, you follow the least significant figures. And lastly, ito na yung last. Actually, hindi pa. Okay, last part na. So, yun. We have to keep in mind that there are these so-called exact numbers. When we say exact numbers, there are just 3 types of exact numbers. Number 1 is the conversion factor. Second one are the transcendentals. And the third one are the integers or the multipliers. So, ganun lang. So, for example, for conversion factor, sabi dito sa sentence natin, paragraph, is that conversion factors are considered exact numbers. So, ano naman kung exact numbers sila? When we have an exact number, we do not take into account their significant figures. We do not count the significant figures because they are considered infinite, no? Marami masyado to be counted and fixed, no? So, if you're dealing with a conversion factor, then, yan, you don't mind their significant figures, no? Only your given unit. For example, tingin tayo sa problem natin. Ito. Kunwari itong part na to. Kunwari lang daming dinidiscuss, no? Ganun talaga ang life. Welcome to college. Okay, so consider this. We have this conversion, diba? So this is the product, no? So this part is the conversion factor. Okay, so again, sabi natin, we do not mind how many significant figures are there for conversion factors. So basically, we'll just neglect it, or we'll just don't mind that part, no? What we're after is the number of significant figures your given units have, no? So we have 2 significant figures for the given unit. So our final answer should contain 2 significant figures, no? So we will report this as 81 cm instead of the whole 81.28. But for the sake of this discussion, no, kasi ang daming rules, di ba? Alam ko yung iba sa inyo na ba pa, ha? Ganun, no? So, yun. So, for the sake of this discussion, these rules will only apply in this chapter. Okay, after this chapter, pwede na magpahinga yung rules, no? Because we will be dealing with a lot of numbers in the future in stoichiometry and in gases, no? So if we consider significant figures, it will be a very, very tedious work for you. So hanggang dito na lang siya, no? So yun lang. Share ko lang. Okay, so for conversion factors, we do not mind the number of significant figures. So instead, the basis for the final significant figures are the given quantity. Okay. Transcendentals. What are transcendentals? Now, when we say transcendentals, these are numbers that are irrational and infinite. For example, pi. Ginamit natin kanina, pi. That's why I told you not to write pi as 3.14. So that is not the pi, no? 3.14 is a rational number. We can express it in fractions, no? Yun kasi one term, one way to know if it is a rational or not, no? You're able to write it in a fraction. But pi, this is never ending, and hence we cannot approximate this very much, no? We cannot write this as a fraction. So, yeah. Since it has an infinite number of significant figures because it is exact number, it means we will disregard this, no? So, hindi porket nag-multiply sa pi, you will report all the digits all the way, no? No. You don't mind the pi na lang, no? So, ganun. The last one would be the integers, no? So, for integers, these are multipliers lang. These are single digits, no? That is accompanied usually with a number that contains a significant digit, no? So yun, for example, 9 here, this is just an integer, just a multiplier. So we do not mind the number of significant figures it contains, no? So this contains 2 significant figures, so our final answer should also contain two significant figures. So yun lang, no? And before I end, no, let's talk about accuracy and precision since we are in measurements, no? So when dealing with measurements, there are two types of characteristics, no? We have accurate measurements and precise measurements, or both. When we say accurate measurements, these are measurements that are close to the true value or the accepted value. But for precise measurements, these are values that are just close to each other but are far from the truth. No? Dikit-dikit lang pero hindi tama. So precise yon. So for the last part, we have this one. Sure, nawawala boss. May ano naman tayo, recording. Upload ko na lang, watch nyo lang doon. Sige. So for the last part, we have this one. Ano tawag dito? Yung pagkalat-kalat yung data nyo. If your data are scattered, no, that means you are not precise and not accurate as well, no? So yun. So the difference between the two, accuracy tells you how close you are to the true value. Precision just tells you how close you are to the other measurements, no? So yun lang naman, no? So I think that's all for today's meeting. And for the next meeting, we will answer more of these worksheets, no? Marami pa tayong sasagot ng questions dito. So yun. If you have intermittent data connection, wait nyo na lang yung upload ng video. Ayan. So I will end the recording. So do you have any questions?